G'day everyone and welcome back to another Tech Talk Tuesday here at Treadwell. Edward Titley is my name. If you're joining us for the first time, welcome. We hold these sessions every second Tuesday at this time, so 1:30 in New South Wales. Sorry, we're a little bit late starting today. And we cover a variety of topics in relation to FRP and designing of FRP structures and all those sort of good things. So thanks for joining, and if you've joined previously, welcome back. Today we're having a look at resin selection. It's something that we get asked about often by our clients, and we have done this webinar before a year or so ago, but we thought it was probably timely to do it again based on some queries we've been getting in relation to resin selection, what resin is and why resin selection matters really. Why should you bother to specify a resin or choose a particular resin? So we'll kick off. We'll have a live Q&A session at the end. Try and answer anything we can here and now live. Otherwise, happy to take questions on notice and respond back to you in due course. And just before we start, a quick note that obviously we're discussing general advice here today. We're not discussing site-specific requirements. So what we say is general in nature, and if you have any site-specific requirements or constraints you'd like to discuss, we'd be happy to do that on a case-by-case basis. So yeah, what we're saying today is general, shouldn't be taken as advice for your particular site, but just some guidelines and some rules of thumb to adhere to. So before we start on the importance of resin selection, what is resin? So as you may be aware, if you're familiar with FRP products, there's two main constituents to an FRP product. FRP being fiber reinforced polymer. You may also know the term GRP, glass reinforced polymer, or GFRP, glass fiber reinforced polymer. So they're all an acronym for the same thing. Effectively, it's a fiber reinforced polymer. The product we supply is typically glass fiber reinforced, so it's a GRP product. So there's two constituents to that. One is the glass or the reinforcement fiber, might be carbon, might be something else in other cases. And the second part is the resin. So the resin is the polymer part. It starts life as a liquid, and then when we're finished making the product, it's a solid, giving us the polymer part. So with that in mind, resin selection, why would I need to specify my resin? What difference does it make? So look, appropriate resin selection is a critical part of getting the proper performance from your FRP product. So probably the best analogy I can give is resin selection is like coating spec or a paint specification for a steel structure. So that coating specification is going to dictate how the product does in relation to exposure to chemicals, exposure to corrosive substances, these sort of things. So for a moderately exposed structure, you might have a hot dip galvanized. If it's exposed, if it's exposed to chemicals or something like that, you might have an epoxy coating on it, or you might do a duplex gal and a galvanized and a wet spray coating, for example. So resin selection is a bit like that. You would specify a coating for a steel structure for proper performance, and we would recommend that the same is done in relation to FRP to ensure their long-term performance. So there's a few things to think about when we're specifying a resin. We've just put a few examples here together to have a bit of a think about. Firstly, we'd review the environment the product will be installed in. So it might be a public infrastructure product where we'd expect exposure to salt water or something like that. It might be an industrial site where we'd have specific chemicals or reagents on site. If it's, say, minerals processing or something like that, we'd know what those reagents are, or we'd need to identify what they are and ensure that we specify a resin system that will be resistant to those. Another example might be a water treatment or a sewage treatment plant. Now, sewage treatment, H2S, is often present in sewage and hydrogen sulfide, and there might be chemicals used as part of the treatment process. We'd need to identify those and once again specify a resin type that will be resistant to those. If that's not done, then the product is going to deteriorate structurally and will need to be replaced prematurely. The point of doing FRP for a structure is, in my opinion at least, a long life cycle or low maintenance structure. So by specifying the right resin type, we're going to maximize the possible lifespan. Considering required chemical resistance, we've already kind of mentioned that. Water treatment environment could be H2S exposure, could be reagent exposure, minerals processing. Might be acid sulfate soils if we're doing a public infrastructure environment, the pile or a pier posted below ground. We might need to consider a resin system that's suitable to be durable in that environment. Consider any required heat or fire performance, specifically important in underground installation like rail tunnels, for example, or underground mining. Or also another example we come across is food processing, where the product might be being installed in a freezer or as an access structure to a large oven. These are things we need to consider to ensure that we specify the right resin that's going to perform in that environment. And lastly, we need to consider the expected design life. And this, to a certain extent, is related to resin, but also related to the structure as a whole or as an entity. Especially the American Composite Manufacturers Association, but the design standards typically give different design or different methodologies for different design lives. So we need to be clear at the outset of the project what design life we're looking for, and that would help us to dictate the right resin to be durable in that environment, especially where there's chemical exposure or something like that, and also to undertake the design methodology in a way that will facilitate that lifespan. Here at Treadwell, we offer three main resin types, or three commonly used resin types. Obviously, there's a variety of others for project-specific requirements, but we'll just touch on the three main resin types here today. If you'd like to discuss something specific to your project, then by all means, let's set up a conversation around that. So, our I-series resin is an isophthalic resin. What that is an unsaturated thermoset polyester resin. It's resistant to rot and corrosion, so won't be subject to attack by termites, won't rot like timber does with exposure to water and so on, and obviously is resistant to corrosion in the sense it won't rust or oxidize in the presence of something like salt water. As do all our X-series resins, so the I-series, the V-series, the P-series, they all contain fire retardants and UV stabilizers, so these are additives to the base resin to provide us a fire performance according to the BCA standards, as required for some applications, not all, obviously, depending on the actual use case of the product, and also AS 1530 Part 3 and some site-specific standards that we might encounter from time to time. Lastly, the I-series product is also tested to AS 4020, which states that it's suitable for use in potable water storage, so there's no leaching of unsafe substances into potable water or something like that when the I-series product is immersed in there. And in addition to public infrastructure and water storage and so on, intermediate chemical resistance, so splash and spill type chemical resistance for lighter industrial areas. One comment I will make is that we wouldn't typically recommend an I-series product for extreme cold or heat situations or conditions. And it's important to understand when we talk about heat in this context, we're not talking about the sun shining on a product or something like that. We're talking about a sustained, continuous, either high or low heat situation. When we'd encounter those high heat, two examples come to mind. One is mine processing for a roaster. And the second example is food processing around an industrial oven or something like that. The structure installed close to that would sit in an environment where it's continuously exposed to an elevated temperature. And extreme cold example that comes to mind is also food processing. We do platforms in blast chillers and industrial freezers for food processing, where once again that product is continuously installed in a low temperature environment. So need to be mindful, and we'll have a look at specifically elevated temperatures a bit later on in this presentation in relation to what that does to the performance of the product. V-series is a vinyl ester product. Vinyl ester resin offers chemical resistance for acidic and caustic substances, along with better mechanical strength in high and low heat. We'll have a look at that second part shortly. But in relation to the chemical resistance, we widely see this product used in wastewater treatment. As we mentioned earlier, H2S exposure is a good one, or some of the various chemicals that the product might be exposed to as well. Mine processing or minerals processing is another one where the product could be exposed to reagents used in that process, and we wanted to ensure that the product's going to be able to withstand that and not deteriorate as a result of that exposure. As I mentioned previously, all our resin systems as part of the X series range, so the V series, I series, P series, all include a UV stabilizer and a fire retardant, and not specifically related to the performance in this regard, but also all include color as well. So the color you see is not a coating, it's incorporated throughout the product. So we'd also recommend the V series for use in areas of constant low or high temperature. And we've mentioned blast chillers in food manufacturing, mine roasting equipment, those sort of things. The V series product does better in that environment. It maintains its mechanical properties at higher temperatures and also resists becoming brittle at lower temperatures, which the I series product doesn't do so well in. So something to think about there. And then the last resin type that we commonly would get involved in is P series resin. P series is a phenol formaldehyde resin, ideal for tunnels and offshore oil and gas. And that's due to two specific characteristics. One is the very high heat resistance, and second is the low smoke characteristic of the product when a fire is encountered. So for use in some of these facilities, the ASTM F3059-15 test is applied. Level 2 test is what this product complies to, and it's a standard for flammability and structural integrity. What that means is how the test works for that is the product exposed to a heat of a particular threshold for a set time, and then a loading is applied, and the product must not fail or yield when that loading is applied. Happy to undertake that discussion in due course or offline as to the performance that's required and where phenolic product would be necessary. Not a common one, but needed in those environments. I will just say, and this might preempt some questions that come up, the other aspect of resin selection is cost. Now, if no spec is given, as we know, lowest common denominator becomes cost, and therefore, especially in a chemical environment, we might get a product that's not fit for purpose, that's going to give us a non-optimum design life. So hence we'd say specify resin to get the performance you want. By way of example, if we say that an I series product is $1, then a V series product will be about $1.25 or $1.30. P series will be in the order of $4 to $5. So it's a reasonable cost increase. And that's why I'd say it's not a commonly used item, but it is necessary in some applications. As we mentioned, the common uses for the P series product, underground, where fire performance is critical, and offshore facilities. So a bit of an overview of the resin types. As we've mentioned, V series offers the best chemical resistance, P series offers the best fire resistance. All the products are fire retardant, and all the products are non-conductive, and we can see that once again that P series offers the highest temperature performance. Caveat: this is specifically relating to heat in this example, and the vinyl ester product is better than I series or isophthalic. So lastly, just before we wrap up with the Q&A session, sorry we're running a little bit over time. Temperature. Now we've mentioned temperature, and by that we don't mean the sun shining on it or something like that. Hot day, cold day. We mean sustained, continuous temperature exposure. So mineral processing, roasters, food manufacturing, ovens or freezers, these sort of constant temperature environments. So as we can see, there's a difference in the way the products react both by way of the ultimate stress capacity and also the modulus of elasticity, or E value, of the product. I won't read the chart at the table out to you, I'm sure everyone's capable of reading, but what we can see is that at 65 degrees, by way of an example, the polyester resin is at 50% of the original ultimate stress, and the vinyl ester product is at 80% by way of example. So in those environments, we'd consider a vinyl ester resin, and as per the design standards, there'd be a factor applied to cater to or to consider that the loss in ultimate stress capacity. Once again, we can see the same with the E value at 37 degrees. Both products are at 100%. 65 degrees, we see that polyester is back to 85% of the original value. Vinyl ester is at 90%. And once again, 79, 80, and 93 degrees, polyester is not recommended for use in those situations, and vinyl ester is at 88 and 85% respectively. So we can see that there's a reduction in those factors for both products, but you'll note that the vinyl ester product maintains its properties for a lot longer, or to a lot higher temperature. Happy to always discuss, obviously on project-specific bases, if that's a word. Always up for a discussion if you're not sure whether you should consider something like this for your application, or which resin to specify, or anything like that. Just let us know. Always happy for a discussion. hello@treadwellgroup.com.au, or give us a call, 1800 246 800 in Australia and 0800 244 600 in New Zealand. Now stay online for a little Q&A session. Got one question here from Max in relation to the design life of the resin. So we offer the, what I'm about to say may counteract itself to start with, but bear with me. We offer the same design life on all the resins, all the resin systems, based on the fact that they are used in the proper application. So if you wanted a 50-year design life for your structure, for example, and you had that structure as a jetty exposed to salt water, following the proper design methodology for a 50-year design life, we'd expect an I-series resin system would be suitable. If that same structure was in a sewage treatment plant or a mine processing facility, we'd apply that 50-year design methodology, and we'd need to use a V-series product, for example, to meet that design life. I'm not sure if that makes sense or that answers the question, but the design life we would offer is based on the right product being used in the right application, if that makes sense. So whilst we'd offer 50-year design life, or if you wanted to go to 100-year design life with that design methodology, once again, it would be dependent on the right resin system being used in that environment, rather than applying shall I say, a blanket rule of product X has a design life of Y years. That seems to not, in my opinion, take advantage of the different resin types on offer. We want to maximize what we're using, or maximize the benefits of what we're using, if you like. Question from Martin in relation to the maximum skin temperature of FRP when exposed to direct sun in a hot environment. Look, that's a question I can't answer for you here and now. What I would say is that FRP is a very poor conductor of heat, as well as electricity, but heat in this instance. What we've typically seen is the surface temperature of the product in sunlight, and slightly dependent on colour, wouldn't typically become objectionable, if that makes sense. So happy to discuss in more detail once I get some details around your specific application, what you're thinking of, or if you'd like a sample to try, by all means, just drop us a line if you wouldn't mind. hello@treadwellgroup.com.au, and happy to discuss. Happy to discuss. I'm just like to confirm whether you're specifically meaning from a pedestrian comfort perspective, someone walking on the product, or whether you are thinking in relation to the skin temperature or surface temperature of the product, maintaining its structural properties. in relation to another question from Max, polyester resin on the last slide. So the isostatic resin or the I series product is a polyester resin. Phenolic is a different animal altogether, and I haven't discussed that in these charts. If you're needing to use phenolic from a fire performance, I'd take that discussion up on a case-by-case basis. But on the last slide, polyester resin is I series, and vinyl ester is obviously B series. Hope that makes sense. Stay on for another half minute in case any other questions come through. And just before we finish, also, I think there should have been a poll that went out to all of you that are attending. If you'd be happy to please answer those couple of questions, that'd be greatly appreciated. Just a bit of feedback on the content we discuss, and any other topics you'd like discussed. Please reach out, drop us a note. That would be greatly appreciated. Another question, just on Martin's has added to his question. Thanks, Martin. In relation to mid-wall temp, my experience or understanding of something like mid-wall temp is in relation to a boiler tube or something like that, where we've got steam traveling through and what the external temperature would be. I don't have an answer for you here and now on that in relation to FRP, but happy to have a discussion and get some info for you. So yeah, if you'd be happy to drop us a note, please, hello@treadwellgroup.com.au. We'll take that discussion up once we have a bit more application specific or details. Thanks, everyone. Appreciate you joining. Any more questions, if they come up, please drop us a note or give us a call. Always happy to chat, always happy to have project-specific discussions. And yeah, feel free to reach out if there's anything we can help with. Otherwise, we look forward to seeing you in 2 weeks for another Tech Talk Tuesday. Thanks very much. Have a good day.